Welcome back. This is an Aleks training video expressing the concentration of an intermediate in terms of the concentration of reactants. And I am recording this on a dark and stormy night, and you can hear the thunder. All right, if you're going to give a rate, and this is things that we've done before, the rate is going to be equal to a constant, times the concentrations of the two reactants or more than or whatever the reactants are. So the reactants in this case is going to be NO and O2. All right, now I'm going to have to be creative for just a little bit. Let's imagine that we were going backwards and we were doing a reverse reaction. If we're going backwards, then these two guys would be your reactants, and this would be your products, okay? Whenever you're doing a reverse, normally you're just going to put a subscript to the -1 to show that it's something backwards, okay? So let's just do that. Let's say I've got k to the +1, which just means that I'm going forward, okay? So k to the +1 going forward. And the rate going backwards will be equal to rate of the k to the -1, just meaning that I'm going backwards. In this case, I can't do NO and O2 because that's on the left. I flipped it in my mind, and now I'm going backwards. So I am going to say that this is going to be times the concentration of NO2, O. Okay. Now I said be creative because what we're aiming to do in this example is we're going to solve for one of these concentrations. Lots of times you're going to make an intermediate. It's a temporary product that then is used up to make the final product. And those are very hard to measure because sometimes they're very, very fast and there's no way to really measure them well. So you have to infer them, okay? To do that, you're essentially taking the idea that if I have a forward rate, let's say I have a movie of some blocks knocking down, okay? And I start the movie and I record the blocks knocking down and then I stop. Now I play the movie backwards. The same rate of knockdown going in one direction is the same rate of build back up going in the other direction. Okay, so if I have the rate here in this case, whatever the rate is, whatever the time it takes, the speed that these guys are breaking apart to form new stuff, it's going to be exactly and see, this is my products, it's going to be the same rate going one way as exactly is backwards, as these products are going to be broken down to go backwards. Okay, that's just the idea. If I'm going in one direction and has a certain rate, then the buildup is exactly the same as the breakdown was on the other side. So if we know that this is the rate law of a forward reaction and this is the rate law of the reverse reaction, these two rates must be exactly the same since it was the same reaction. Since that's true, I can set them equal to each other. Okay, so I'm going to say K sub 1 times NO times O2, okay, equals K to the -1 times NO2 times O. Okay, so those two rates are equal to each other. Now I can solve for one of them in terms of all of the other. Okay, if I know concentrations of the ones that I can measure, then I can apply concentrations of the ones I can't measure based on the others. Okay, so I'm just going to solve, in this case they're asking you to solve for O2. Okay, it says, let me go back, write an expression that gives the equilibrium concentrations of O2 in terms of all the constants plus the concentrations. All right, so just get O2 by itself. Okay, O2 is here. It means these guys are in the way. Let's divide them out. And I'm going to have O2 equals K to the -1 times NO2 times O over K to the 1 times NO. So just for clarity, you can get the constants kind of their own fraction. So I could say this is K to the minus 1 over K to the 1 times the concentration of NO2 times O over NO. Okay, this is just a little bit of algebra. I think it's not very hard. Trust you to get it.